Welcome to Rges Algebra 1. This is Lesson 19B. We're going to be covering Section 7.10, which has to do with using simultaneous equations to solve word problems, 9.1 and 9.2. Now we're going to skip over Chapter 8, partly because it deals a lot with word problems, again, that I'll be working with slowly, and then also because it talks about scatter data and some things that aren't normally covered in a Algebra 1 book, and we will plan on coming back to that later, but I want to get into the next major algebraic topic sooner. So before we do that, I need you to go get your book. We're in 7.10 and turn to page 321. We're going to walk through some word problems together. So go ahead and pause and come back when you're ready to go here. The first word problem on page 321 says, Swiss cheese and Limburger cheese cost different amounts per kilogram, but you do not know how much. A box containing 3 kilograms of Swiss and 2 kilograms of Limburger costs $24.40. Another box contains 4 kilograms of Swiss and 5 kilograms of Limburger, and it costs $47.70. Assuming that these figures are for the cheese only, not the box, how much is each kind of cheese worth per kilogram? So I have two questions. How much does the Swiss cost per kilogram, and how much does the Limburger cost per kilogram? So we're talking about cost of two different things. That would be considered, in my mind, I'm going to think, I have two variables. So if I can set up two equations with two variables, I can solve by simultaneous equations. So let's go ahead and assign a value or identify what our variables are going to be and write our two equations. Now, once I've identified my two variables, I want you to think if they have given you two equations. And they certainly have by two different scenarios of what's contained in the boxes and how much the boxes cost. So go ahead and make an attempt yourself to write what you think those would look like, those equations, and then put it on pause for a second and then come back. And this is what you should get. They tell you that you have 3 kilograms of Swiss plus 2 kilograms of Limburger equals $24.40, and 4 kilograms of Swiss plus 5 kilograms of Limburger equals $47.70. Remember my my parenthesis over here, or my bracket over here, brace, I guess is what they call that, is indicating that I need to solve these equations simultaneously. If I multiplied the first equation by 5 and the second one by -2, so my signs are opposite, my Limburger will drop out and I'll be able to solve this equation. So he steps you through the solution. So I won't bother doing that. What I want to do is talk through a little bit how to set up the equations. Let's go to example 2. Example 2 says, according to information on the labels, cereal A contains about 38% sugar and cereal B contains 46% sugar. So go ahead and stop. Well, let's go ahead and, we've got 38% and 46%. I'm going to write that down. And part A says, what percent sugar would there be in a mixture of 100 grams of A, cereal A, and 200 grams of cereal B? What percent? So we want to know the percent of sugar in a mixture. Well, this is going to be a two-part problem. The first part, I will figure out the amount of sugar, and then I will figure out the percent of sugar in the mixture. Okay. To figure out the amount of sugar, I would have to calculate I would have to take 0.38, the percent of sugar in A, times the amount of A, which they give me as 100 grams. So that would give me the amount of sugar in A, plus 0.46 is the percent of sugar in B, times the amount of sugar in B, which they give me. And that's going to give me the amount in B, and this will give me as an answer the amount of sugar in the mixture, which is step 1. So hopefully that's clear to you. Now to figure out step 2, the percent of sugar, I would take that answer, the amount of sugar in the mixture, not in A or B, okay, and I would divide it by the amount of cereal. That would give me total in the mixture. Okay. Well, what is the amount of sugar total? What is the amount of cereal altogether? It's 100 plus 200 more. So I will take this, the amount of sugar, and divide it by 300. Okay. So pause that, make sure that's very clear to you, and then we'll look at part B of the problem. Part B says how many grams of each cereal would be needed to make a kilogram of the mixture. Okay, well, of a mixture containing 40% sugar. So if A represents the grams of cereal A, and B represents the grams of cereal B, altogether, I was going to put an X there, sorry. A, how much we have of A, and B, how much we have of B, equals 1 kilogram, or 1,000 grams. So that's equation 1. Now thinking about sugar, I would have 0.38 of A, the amount of A, would be the amount of sugar in the first one. 0.46 times B, the amount of cereal B, would give me the amount of sugar in the second one. And for the whole mixture, I'm going to get 0.40. That's what they give me in the question in B. A mixture containing 40%. Well, what is A plus B? The amount of both of them together? The same as this, right? Together they have 1,000 grams. So these are going to be my 2 equations that you need to solve simultaneously. Again, he works you through the solution, and pay close attention to that, but I'm trying to explain to you again with a little more detail the logic on how he's getting these equations. Now let's look at the next problem, example 3. Now this is a current problem, and we have current problems with both water and air currents. We could either travel with the current or against the current. If I am traveling with the current, I'm going to get there quicker, right? This will be faster. If I'm traveling against the current, I will be slower. And if you've ever been in a canoe going down a river, you know that to be so. Okay, so it tells me in the problem a submarine sails submerged for a distance of 150 nautical miles against a current of unknown speed, taking a total of 10 hours. It returns to the starting point going with the current in 6 hours. So our time is going to be the same. I'm sorry, not our time. Our distance is going to be the same both ways. So let's think a little bit about speed. If I'm going in my car 40 miles an hour, and so this will be my speed, and I'm going for 3 hours, this will be my time. Altogether, that's my distance. And I think that this is obvious to students just from life experience, but let's make sure we can write it as an equation. So my distance is going to be the same. So I'm going to use this general equation for both the equations I'll set up for the simultaneous. One I will go with the current, and one I'll go against it. So let's put these two ideas together. My speed is going to be the speed of the sub. If I'm going against the current, I'll take the speed of the sub, subtracting out the speed of the current. So for against, you'll take the speed of the sub. I'll talk, let's see, my sub will be, the speed of my sub will be S, and the speed of the current will be C. Okay, so I'll take the speed of the sub, subtracting out the speed of the current, and the time when I'm going against the current is what? 10 hours. That's a 10 in front of there. And that's going to equal 150 is my distance, which he gives me in the original problem. Now, how about when I'm going with? That will be my second equation. Now the time is 6 hours, and I'm going to take the speed of the sub plus, because this is going to help me get more distance, the speed of the current. And that also equals 150. Now I could distribute these out and then solve it as simultaneous equations, but I could also notice very quickly that both 10 and 6 go evenly into 150. So I'm going to do the division first, which is what he does, and that makes the arithmetic much easier. First off, dividing the right side by 10, and I'm going to get 15. And next one, I'm going to divide the right side by 6, and I'm going to get, that'll be 2 for 12, and 30 would be 25. And this then works out very slick and easy. My C's will drop out, and it's a very straightforward solution. So that's how you're getting these, and this same technique for anything where you have a current you're going with or against. Okay. The last example problem I want to step through with you is example 4. The Joneses have 2 insurance policies. The first one pays 80% of those expenses not covered by the second. The second pays 70% of those expenses not covered by the first. Mrs. Jones has an operation that costs $3,000 and is covered by both policies. So we have policy A and policy B. Okay. How much do the Joneses get from each policy? Is the total more than 100% of the $3,000? So we're going to set up 2 equations. Insurance A gives me 80% and insurance B gives me 70%. Let me write down what I know. So insurance A is going to be the cost paid. We want to know what A pays. And it's going to pay 80% of what was not paid by B. Well, the total would be $3,000. Subtract out what was paid by B. On the other hand, B is going to pay 70% of what was not paid by A. What was paid by A? The total minus what was paid by A is going to be what's left over, and you're going to take 70% of that. So hopefully that's clear, and then this would be a good one for substitution. Okay, so these are my simultaneous equations. Now your assignment is going to be trying to use these tricks, and pay attention as he walks you through step by step, because that'll help your thinking, and I only want you to go through the first 10 today. I take it back, I'm sorry. I want you to go through the first 16. Okay, so work through those. Now we're going to move on to 9.1. We're going to start with the idea of prime numbers. A prime number is something that can only be multiplied, or I'm sorry, only be factored by 1 and itself. In other words, 11 is a prime number because if I break that up into factors, the only factors that come out evenly are 1 times 11. That's what we mean by that. No other whole numbers divide in evenly. Our list of prime factors would be 1 is not prime. Okay, so 1 is not prime. So we'll start with 2. 2 is the only even prime, because everything other even number could be divided by 2. 3 is prime, 4 is not. 5 is prime, 6 is not. 7 is prime, 8 is not. 9 is not, it's divisible by 3. 10 is not, all the other evens will not be. 11 is prime. Skip over 12, it's even. 13 is prime. Skip over 14. Skip over 15 because it can be divided by 5 and 3. 16, skip over, it's even. 17, so hopefully you understand how we're getting these. 18 is not. 19 is. 20 is not, 21 is not, 22 is not, 23 is prime. And I'm just thinking, do they have divisors? And you should, if you're comfortable getting that many, that'll probably be as many as you'll need for this exercise. Now, what we're going to talk about next is how to rewrite a number as a product of primes. So they give you the number 144. He shows it to you by first dividing by the first prime. We call this upside down division. That goes in 72 times. Divide again by the first prime. We're going to divide by 2 until we can't do it anymore. That goes in 36 times. Divide by 2 again. That goes in 18 times. Divide by 2 again. That goes in 9 times. And now we can't divide by 2, so go to the next prime, which is 3, divide by 3, and divide by 3. And now we're going to write this as a simplified product by primes and powers. How many times did we multiply 2 together? 1, 2, 3, 4. 2 to the 4th times 3 squared. And that's all there is to it. What we're doing is we're taking a number, any number, and we're writing it as a product of primes. Okay, let me show you one more. 1125. It does it upside down. Okay. It does not go into 2. Does it go into 3? Let's see. 20. Yes. We'd go into 3. Goes in 11. Divided by 3 is 3, with 2 remainder. 22 divided by 3 is 7 for 21, with 1 remainder. 3 goes into 15 5 times. Okay. So can 3 go in again? Yes. So we kind of have to be a little bit sharp with our mental division here. Hopefully you can do this. 15 5 times. Now, 3 does not go in, but 5 will. And that'll go in 2 and 5. And 5 goes in again for 5. Now I have all primes as my dividers. So I can write 1125 as a product of primes, 3 squared times 5 cubed. And that's all there is to it. Now I will show you one other technique. Let's say you're not as crazy about that technique, but it's easier. Let's go to the first one again to just think of the first 2 things I can think of that multiply together. Well, 12 times 12. Neither one of those are prime, so I'm going to have to keep breaking them down. This time maybe I think of 2 and 6. 2 is prime, so I'm going to circle it. 6 is not prime. Maybe over here I think of 3 and 4. Just illustrating, it doesn't really matter. I break them down as the first 2 multipliers that come to my mind. 4 is not prime, but it's broken down in 2 2s. And this is broken down into 2 and 3. And now this way is another technique. We call it the tree method. But I've also broken 144 down into primes. I'm just not insisting on the order that I do it in. Okay, so what does that equal? Well, I've taken 1, 2, 3, 4 2's. So that'd be 2 to the 4th. And 2 3's times 3 squared. And again, there's how you break down 144 into a product of primes. Well, that's the exercise you're going to do today, and that will be 1 through 19 odd. You can use either the tree method or the upside down division method. The last concept is understanding what we mean by exponentiation. If we look here at x to the 6th, what that means is x times x times x. We're taking the base, which is x, and we're going to multiply it together 6 times. There's my base. 1, 2, 3, 4, 5, 6. So if we have x to the 5th times x squared, what I have is 5 x's being multiplied and times 2 more x's. So how many x's in all do I have? If you wrote all that out, you would have 7 x's in all. So when we are multiplying variables, we are adding the exponents. And just writing it out longhand will make that very, very clear to you. Okay. Now what if I did something like this? X to the 4th to the 3rd power. That means I'm going to take x 4 times, and I'm going to take that whole grouping 3 times. And hopefully you won't have to write these all out very many times before you see that in that scenario, I'm going to have 12 x's. Notice what I would be doing here is I would be multiplying. Okay, but it should be obvious just to think about it visually, and you would know what to do. Now, what if we had something like this? 5x, the whole thing cubed. Well, I'm going to take that number cubed and the x cubed. 5 times 5 is 25, times 5 more is 125 x cubed. And I think that gets you through today's assignment.